Hi all. Today we are discussing a chapter Chemical Reactions and Equations. This is the first chapter in our 10th science textbook. What are the learning points that we are discussing here? In this chapter, we are discussing about changes in our surroundings. It mainly include physical and chemical changes. We are also going to discuss about chemical equation. What is chemical equation and how to balance these chemical equations? Types of chemical reactions. There are many types of chemical reactions happening in our day-to-day life. We are going to understand those types. They mainly about combination reaction, decomposition reaction, displacement reaction, and so now let us understand what are the changes in our surrounding. I'll show you some pictures. Try to guess what change is that. Here you can see set of screws which are made up of iron. What happened to those screws? What happened to those screws? Yes, those screws have undergone rusting of iron. Here we have grapes. Grapes, when kept for longer time, undergo fermentation of grapes. What type of changes would these be? Yes, these two are the changes which are involving production of new substance. Hence, it is a chemical change. And we have one system present in our body. Which is the system? Yes, you are right, children. It is digestive system. This digestive system it helps in digestion of food. This digestion of food is also a chemical change. And here a tasty food is being cooked. Cooking of food is also a chemical change. Like this, you may notice lot many changes in our surrounding which can generally be physical or chemical changes. But our concern in this chapter is about chemical changes. Now, let us understand the difference between physical change and chemical change. Physical changes are those in which only the physical properties like color, physical state, that is either solid, liquid, or gas, and density, etc., will get changed. Whereas in chemical change, it includes the change in chemical composition or the chemical properties undergo change during chemical changes. In physical change, generally no new substance is formed, whereas during chemical changes, there will be formation of new substance. During chemical change, sorry, during physical change, very little or no energy is used or released. Whereas during chemical changes, generally it is accompanied by absorption or release of energy. Physical changes are temporary changes, whereas chemical changes are permanent changes. Physical changes are reversible, whereas chemical changes are generally irreversible. So these are the main difference between physical change and chemical change, about which you have already studied in your 7th and 9th standards. Let us understand more about these chemical changes. What are the factors that we can observe during chemical change? First thing, change in state. During chemical change, there may be change in state of matter. For example, when zinc reacts with sulfuric acid, zinc is a granule, that is zinc is a solid which is available as granules. This zinc, when added to sulfuric acid, it forms zinc sulfate, which is a solution. So there is change in state of matter. Change in color. Many a time you might have observed the ripening of the fruits. Green color unripened mango turns to yellow color. So there is change in color, which is again showing chemical change. Chemical change can also be associated with evolution of gas. Release of gas is also one of the factors that we need to observe during chemical change. It's also associated with one more factor, that is change in temperature. During chemical change, there may be increase in temperature or decrease in temperature. Let us now understand what is this chemical equation. Chemical equations are shorthand representation of a chemical reaction. When any chemical change is undergoing, there will be chemical reaction. Those chemical reaction can be represented in short way as chemical equations. These chemical equations, we can represent it in two ways. One as word equation, where we'll write the words of the reactants and the products. Or symbolic equation, where we use the symbols of the reactants and the products. Here is an example of chemical equation. Burning of magnesium ribbon. When magnesium ribbon is burnt, it combines with oxygen to produce magnesium oxide. I'm telling this process of burning of magnesium ribbon in form of sentence. If I want to put it in shorthand, I can represent it the way you are seeing here. That is magnesium plus oxygen giving magnesium oxide. Here you can see image of burning of magnesium ribbon, where magnesium ribbon is burning with bright white flame, and it also produces white ash, which is nothing but magnesium oxide. The above one, it is magnesium above one. This one is of word equation, whereas this one is of symbolic equation. Mg is of magnesium symbol plus O2 oxygen giving MgO. Here arrow mark, left hand side of the arrow mark represent reactants, whereas right hand side of the arrow mark represent products. And arrow mark represent direction of the reaction. In between the reactants, when the reactants are more in number, or when the products are more in number, more than one, then we'll represent the multiple reactants with the help of plus symbol, addition symbol. A word equation shows change of reactants to products through an arrow placed between them. You have seen the arrow mark in between the reactants and the product. Left hand side of the arrow is reactants, and right hand side of the arrow is of products. The reactants are written on the left-hand side with a plus sign between them. Similarly, products are written on the right-hand side with a plus sign between them. The arrowhead points towards the products and shows the direction of the reactions. Now, we need to know very important concept of the chapter, that is balancing of chemical equation. Dear children, from your 9th standard, you have understood that during a chemical change or during a chemical reaction, mass of the reactants are always equal to mass of the products. Isn't it? So this mass of the reactant should be equal to mass of the product. Means if the reactant is having one atom of a reactant, one atom of an element, then on the product side also, it should have one atom only. That's the main basis of balancing of chemical equation. Balancing has to be done to obey the law of conservation of mass, which you have studied in your ninth standard. Let us now understand how balancing of chemical equation can be done with, with the help of PHET simulation. Dear children, here you can see a reaction given. Look at the arrow mark where I'm showing. Here you can see the reaction of formation of ammonia. Ammonia is having formula NH3. It is formed by reaction of nitrogen N2 with hydrogen. Here, in order to balance it, let us first take one atoms of each molecule. One atom of nitrogen, one molecule of hydrogen, and one molecule of ammonia. Here, to understand the concept better, I'll select weighing balance. Dear children, observe nitrogen atom in the reactant side and the product side. In the reactant side, it's having two atoms. In the product side, it's having one atom. In case of hydrogen, in the reactant side, it is 2. In the product side, it is 3. So, we need to balance this. How can we balance it? During any balancing of chemical equation, we need to balance the equation by changing the number behind the symbol or the formula. We are not supposed to change anything which is in the formula or which is in the symbol. So we need to do trial and error method in order to balance it. First, let us try to balance nitrogen. Nitrogen on the reactant side is already 2, on the product side is 1. So let's balance it. On the product side, let us make it as 2. So nitrogen is balanced here. On both the side, it has become 2. You can look at this weighing balance having nitrogen on the reactant side and the product side. Whereas hydrogen has become imbalanced now. In the reactant side, it is 2. In the product side, it is 6. So we need to make it equal. We have to increase the number of atoms in the reactant side, which is 2 to 6. Easiest way is to multiply 2 with 3 to make it a 6. So I'll increase the hydrogen count to 3. You can see now it is being balanced. This is how balancing of chemical equation has to be done. I'll give you one more example of separation of water. Water on electrolysis gets separated into hydrogen and oxygen gas. In order to balance it, first let me take one atom. Yeah. Look at hydrogen. On the reactant side, it is 2. On the product side also, it is 2. Hydrogen is balanced. Whereas oxygen on the reactant side is 1. On the product side is 2. I should make the reactant side as 2. So I should increase the number to 2. So now, oxygen has become 2 here, 2O, and here O2. Oxygen is balanced. But look at hydrogen. Hydrogen 2 2s are 4 it has become. Whereas in the product side, it is just 2. So we need to increase the 2 atoms into 4 by putting 2 behind. Now it is balanced. So this is how easily we can balance the chemical equation. I'll also give you one more example of combustion of methane. Methane is CH4, which on burning with oxygen produce carbon dioxide and water. So let me take one molecule of CH4, oxygen, carbon dioxide, and water. Look at the weighing balance above. Carbon on reactant side 1, product side also 1. You can look at the reaction also here. Dear children, observe the reaction. Dear children, observe the equation. Reactant side 1, product side 1. Hydrogen, reactant side 4. Product side, it is 2. So I need to equal it by making it 2. Hydrogen is balanced. Oxygen on the reactant side is 2, on product side is 2 plus 2, 4. Whereas reactant side it is just 2. So what can be done, dear children? Yes, you have guessed it right. We need to make the reactant side 2 molecules, so it will become 2 2s are 4. This is how balancing of equation can be done. Let us understand more by doing workouts. Today we have understood how balancing of chemical reaction chemical equation has to be done. Now, here is some workout problems to you. Please make note of it. Balance these chemical equations. Very simple equations I have given. You should do trial and error methods. C6H12O6 plus O2 giving CO2 plus H2. First thing what you need to do, put box. Can you see, children? Inside those box, you are not supposed to change anything. Only behind those box, you can write something. I mean, you can write the numbers that helps you for balancing. Yeah, here you can write 6 carbon is there. Here only 1 is there. So I'll write here as 6. Yeah, here 6 carbon is there on the reactant side. On the product side, only 1 is there. So I'll write 6 here. Okay, now oxygen is 6 here. Here 6 to the 12 plus 1, 13 is that. Let me see hydrogen. Hydrogen 12 is here. Here only 2 is there. I need to make the 2 12. How can I do that? Multiplying this 2 with 6. So 6 to the 12. 6 oxygen, 6 to the 12. 12 plus 6, 18 oxygen, whereas here 6 oxygen plus 7, 8 oxygen. I need to make it as 18 oxygen. So here, keeping that 6 aside, I need to have 12 more oxygen. So I'll put the number 6 here. 6 twos are 12, 12 plus 6, 18. Now you can check out again. Carbon 6 here, 6 carbon here. Hydrogen 12 here, hydrogen 6 twos are 12 here. Oxygen 6, 6 twos are 12, 12 plus 6, 18. Here 6 twos are 12, 12 plus 6, 18. This is how balancing of chemical equation has to be done. I have already solved one for you. Let the rest you need to solve by yourself. Fe to O3 plus Al giving Al to O3 plus Fe. NaCl plus AgNO3 giving AgCl plus NaNO3. Sodium plus water giving sodium hydroxide plus hydrogen. Dear children, in the fourth one, purposefully I have given in word equation. Try to convert that into symbolic equation, then balance it. That's all for today. Let's meet up tomorrow with another video. Thank you. we need to balance the hydrogen. In case of hydrogen, in the product side it is 6, in the reactant